at equilibrium. So what does it now? What is the equilibrium constant? Concentration of products upon concentration of reactants. Is the point clear?
Yes.
First condition is if Kc is equal to Qc. If both the values are equal, then what does it mean? It means reaction is at equilibrium. Reaction is at equilibrium. Is it okay? So if both the values are equal, it means that this is the equilibrium value. So if Qc is equal to Kc, it means reaction is at equilibrium. But if Qc is less than Kc, Qc is less than Kc, then what does it mean? Qc की वैल्यू कम है, कम कब होगी? अगर प्रोडक्ट्स का अमाउंट कम होगा. Qc means concentration of products upon reactants. तो अगर मेरी इसकी वैल्यू कम है, कम का क्या मतलब है? Amount of products is more or less?
Less.
Amount of product is less. So if Qc is less than Kc, it means that reaction has not attained equilibrium. वो equilibrium तो पहुंचा ही नहीं है. ठीक है ना? Reaction has not proceeded much to the forward direction. So how to make the reaction reach the equilibrium? It means in this particular case, reaction has not reached the equilibrium. So the reaction will proceed. So the reaction will proceed in forward direction to reach equilibrium. Yes or no? If I am saying इस particular reaction के लिए Kc की value 10 है और Qc की value 5 ही है. 5 का what does it 5 means? It means amount of product is less. Products upon reactants होते हैं ना, it means this value is less. So to make the value more, so it has to proceed in forward direction. Only then this reaction will reach the equilibrium. Because if they are at values are equal, it means reaction are at equilibrium. If the values are different, it means reaction is not at equilibrium. So agar Kc ki, if the value of Kc is less, it means that to reach the equilibrium, it has to proceed more in the forward direction. Is the point clear? So we have to increase the value of Qc. So it means the reaction has to proceed in the forward direction. Now what will be there if suppose I am taking this third point, if Qc is more than Kc. If Qc is more than Kc, suppose Qc ki value is 15. So what happened? What does it mean? To attain equilibrium, in which direction it has to proceed? Value of Qc is backward. If this value is 15 and this value is 10, have to decrease the value. It means to attain the equilibrium. To attain equilibrium, the reaction has gone in the forward direction. So to attain equilibrium, reaction will move in backward direction. Is the point clear? To attain the equilibrium, because we have to decrease the value of Qc. It means reaction will proceed in backward direction. So these are the very important points. That is the relation between Qc and Kc. So if Qc is less than Kc, so we have to increase the value of Qc. So the reaction will proceed in forward direction. But if the value of Qc is more, then the reaction will move in backward direction. So we can predict the direction of our reaction. In what direction the reaction will proceed. Okay? Is the point clear? Now, another thing is that, suppose, okay, I'm rubbing this. If you have to note something, you can note. We have got numericals based on this. Okay?
Ma'am, wait.
I am just putting the board. Just wait. Okay. Okay, now I am coming to the next topic. If I am simplifying the reaction, that is the reactants are converting into products. So what is the meaning of Kc? Products upon reactants. Now, if I am saying that the value of Kc is very large, what does it mean at equilibrium? If the value of Kc is very large, what does it imply? Which is more, products ka amount or reactants amount? Aishwarya? If I am saying the value of Kc is very large, what does it mean? Kc means products upon reactants. Aishwarya, can you tell me what does it imply?
That, ma'am, that the reactants, the concentration of reactants is less.
Or the products is more? Is it
Yes,
okay?
ma'am.
That at
Yes,
equilibrium,
ma'am.
amount of products formed is very large. That is, reaction has almost reached completion. Reaction has almost reached completion. Now, what does it mean in simple language? Suppose I am taking reactants 1 mole. Initial concentration of reactants is 1 mole, and when they are forming its products, it is 0. This is the initial. No need to write this. This is simply to understand this point. Okay. So if I am saying at final concentration of reactants, suppose 1 basis 0.9 mole is react. So it will be 1 minus 0.9. Suppose 0.9. So 0.1 and the products formed is 0.9. It means that most of the reactants are converting into products. So these are those reactions in which at equilibrium amount of products is very large as compared to the amount of reactants. That means most of the reaction is going to completion. Is it okay? But so Kc large means generally Kc ki value if it is very large means 10 ki power 20, 10 ki power 10 and so on. Okay, very large. Suppose I am saying 10 ki power 10. So this value is very large. So it means that most of the reactants are converted into products. But if Kc is very less, if Kc is very less, suppose I am saying that Kc is equal to 10 raised to power minus 25. Minus 25 means its value is very less. So what does it mean? It means that if I am taking same reaction, reactants
has just started.
Yes. So if initial it is 1 mole, it is 0 mole. So it means that reaction has not taken place much. So if initial final I am saying out of 1 mole, 0.1 is reactive. So it is 1 minus 0.1. So that is 0.9 moles of reactants and 0.1 mole of products. So it means that at equilibrium, the products has not been formed. Only the reactants most of the reactants are left. It means reaction has not proceeded. Reaction has not proceeded much in the forward direction. Yes or no? It means
Yes,
at
ma'am.
equilibrium, reaction has not proceeded much in the forward direction. Only certain amount of reactants are converted into products. Then the equilibrium is reached. So at equilibrium, concentration of products is very less. So if Kc is very less, then it means that the concentration of products is very less. Most of the reactants are left. So it can be like this also, 1 minus 0.001 or whatever we can say, 0.009, and it is 0.001. It means products are not being formed much. Most of the reactants are left. This is the meaning that if I am saying Kc is very small. But third point, if we are saying that Kc is intermediate, if value of Kc is neither small nor large. Large means, जैसे मैंने I have taken the example 10 raised to power 10. This value is quite large. Small means 10 raised to power minus 5, 10 raised to power minus 10. Now suppose I am saying is that Kc is equal to 45 or Kc is equal to 0.5. So neither this value is too large nor too small. ठीक है ना? We are taking the 10 की powers. अगर 10 की power value very high है, then value of Kc is very high. If 10 की power is very less, then Kc is very less. But if 10 is not much, then what does it mean? What does it mean? So it means that at equilibrium, both reactants and products are present in good amounts. It means a considerable amount of reactants are converted into products. So we are having both reactants and products in the good amount. Okay? So that generally what we are taking these values as between 10 raised to power minus 6, yeah, minus 3 to 10 raised to power 3. Okay, generally this value is between 10 raised to power minus 4 to 10 raised to power 4. So if this is a value, it means that both the reactants and products are in good amount. Okay. So we have done these two topics, number 7.6.1 and 7.6.2. Now I am taking few again more numericals based on the topic. Okay. Let me take okay, NCERT examples you will read. So I am taking the back exercise questions I am trying to cover. If I am taking is question number 7.23. I am taking is question number 7.23. Then I will be taking more questions. 7.23. Back exercise. Okay, Sayam, now you read the question. Say 1.23. Back exercise. I am waiting. Okay, Ayush, can you read the question? Ayush? Ayush, Akshita? Say yes, ma'am, both of you. Ayush?
Yes, ma'am.
Okay. Now, can you read the question, Akshita?
Ma'am, can you please confirm the question? My book is old version, so I don't know if the question is correct or not.
start reading, I will tell you. That's not an issue.
At 1127 Kelvin and 1 atm pressure, a gaseous mixture of carbon monoxide and carbon dioxide in equilibrium with solid carbon has 90.55% carbon monoxide by mass. Calculate Kc for this reaction at the above temperature.
Okay, yes. So it is means that what we are taking is a gaseous mixture of, can you repeat again? A gaseous mixture of carbon dioxide and carbon monoxide.
Yes, ma'am.
And 90.55% of carbon monoxide by mass. And it is in equilibrium with solid carbon. The equation that is given to us is carbon solid plus carbon dioxide gas. They are in equilibrium with carbon monoxide gas. This is the equation that is given to us. What we have to calculate is Kc. Okay, now what is the suppose initial amount? Percent means we can take out of 100. What is the initial concentration? Akshita, you only start telling what is the initial concentration? But it is being given by mass. By mass. So initial amount I can take. Initial amount. Okay, do we consider the solid concentration? What is the concentration of pure solid taken as?
M1.
1.
One.
When we are doing the formula, we don't take into count the concentration of pure solid. And another thing is that what we are given is the pressure. Okay. Now suppose if total mass, I am taking the total mass of these two is suppose 100 grams. Yeah, or what we can write if gases in दोनों का mixture है ना, if total amount of carbon dioxide and carbon monoxide is suppose 100 grams. So what is the amount by mass? And that's why I am taking in amount. So what is the amount of carbon monoxide at equilibrium? If total mass of these two is 100 grams, what is the mass of carbon monoxide at equilibrium? Yes.
90.55.
90.55 gram. ठीक है ना, percent by mass means 90.55% by mass. By mass means we are taking it in grams. So it means at equilibrium. This is given at equilibrium. Amount of carbon monoxide is this one. And what is the amount of carbon dioxide? Yes.
9.45.
Yes, 100 minus 90.55, which is equal to 9.45 gram. So what we are given is the amount. Now, can you calculate the number of moles of carbon monoxide? What is the formula for calculating the number of moles? Agnish? Bhavya?
May I?
Okay, you tell me.
Ma'am, number of moles is equal to molar mass upon given mass upon molar mass.
Yes, Aryan, what is the mass of carbon monoxide?
90.55.
Then what is the molar?
128.
It will be
28.
44.
ठीक है, और इसको हो गया 44. Now calculate the number of moles. So it will be roughly 3.23. Okay, and it will be 2.2. Then you can calculate up to one more digit.
0.215.
Okay, 0.215 moles. Okay, so what we have got is the number of moles. But now what we are given is total pressure. What we are given is that total pressure is 1 atm. Okay, can you calculate partial pressure of carbon monoxide? Do you remember the formula for calculating the partial pressure? It was in the Dalton's law Partial pressure of a
Yes, ma'am.
component.
Partial pressure is PV is equal to nRT.
Yes, but from the number of moles. There is one more formula. Mole fraction of component.
Mole fraction by concentration.
Mole fraction into total pressure.
P total. Mole fraction into P total. This was the formula. It was in chapter states Dalton's law, and I told you that this formula is very important. The partial pressure of a component is equal to its mole fraction into total pressure. So if we have to calculate the partial pressure of carbon monoxide, it will be equal to a partial pressure of mole fraction of carbon monoxide into P total. So what is the mole fraction? Number of moles. Mole fraction means number of moles of carbon monoxide upon total number of moles. Total number of moles means this into P total, that is 1 atm. So this will be equal to 3.23 upon 3.23 plus 0.215 into 1. So it will be approximately 0.938 atm. Okay. So what we are calculating is the partial pressure, because in this question we are given suppose amount grams में given and number of moles भी निकाल लिया, but we are given the total pressure. Okay. So क्योंकि आपको कार्बन डाइऑक्साइड का भी given है, कार्बन मोनोक्साइड का भी है, गैस का तो solid do not have any pressure. The pressure is only of the gases and the total pressure is given to us as 1 atm. So we have to make use of this expression. Now, for calculating the partial pressure of carbon dioxide, it will be equal to mole fraction of carbon dioxide into P total. And what is total? Mole fraction is 1. So if I am knowing the mole fraction of this one, so the mole fraction of this will be 1 minus 0.938 into P at mole is 1 atm. Otherwise, you can calculate, but we know that total mole fraction is equal to 1. So if the mole fraction of carbon monoxide is 0.938, it will be 1 minus 0.938. So it will be
0.062.
0.062 atm. So now what we know is the partial pressure of both of them. So we are not finding in terms of concentration because what we are given is the pressure. Okay, so this is a slightly different type of question. Here we are given the pressure, so we are making use of this. Okay, now what we can find out is Kp, not Kc. Now Kp is equal to partial pressure of products raised to the upon partial pressure of reactants. Pure solid ka to 1 hoga. So I am not taking into account this. Is it okay? So first step, what we are finding out is Kp here. So we have to make use of this data. Partial pressure of carbon monoxide is 0.938 whole square. And this is 0.062 this. So you have to solve this. Okay. So I am not doing the calculation. If I am solving this, the answer will be approximately 14.19. What I have got, first we are calculating the value of Kp. Now we have to convert Kp into Kc. Okay. Rishabh, what is the relation between Kp and Kc? Rishabh? Yesterday we have done the relation between Kp and Kc.
Hey,
Rishabh, are you there? I want answers from other now. Yes. Who else can tell me?
Ma'am, may I?
May I?
ma'am, Kp is equals to Kc into RT raised to the power delta Ng.
Okay. Now, Rohan, you will be telling me further. Rohan and Sanket. Rohan, Sanket, Sahil, I want the answers from you, okay?
Yes, ma'am.
1 minute. My blackboard is visible?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, ma'am.
Now, if I am taking Kp is equal to Kc RT delta Ng, Rohan, what is the value of delta Ng? Calculate it from this.
One. Ma'am,
How is it one? What is
ma'am,
delta?
0.
What is delta Ng? Change in number of the gaseous moles. Number of gaseous moles of products minus reactants. Now, what is the product? 2 carbon monoxide. इसमें इसका तो है ही.
1.
You are opening the solutions and telling it from there, okay? So you should be knowing how to calculate. So delta Ng is equal to 1. So now what is Kp? Kp is 14.19 is equal to Kc value of R. In which unit we have to take the value of R?
मैम, हमको 0 नहीं होगा 8
Yes.
मैम 2 मोल्स है ना सी और कार्बन मोनोऑक्साइड के.
हाँ, तो ये हो गया 2 माइनस प्रोडक्ट्स के हो गए 2 प्रोडक्ट्स की गैसेस मोल्स माइनस रिएक्टेंट्स. ठीक है, प्रोडक्ट्स के 2 मोल्स, रिएक्टेंट्स में कार्बन का तो 0 है ना, कार्बन इज अ सॉलिड. So I am taking the number of gaseous moles. Is it okay?
Yes.
In the reactants, number of gaseous moles is over only 1. What will be the value of R in ATM?
0.1
0.0821 liter atmosphere mole inverse Kelvin inverse, because we want the value of R in ATM. Okay, so value of R won't be given to you. You have to use it correctly into temperature. Temperature is 21127. So Kp is equal to Kc R into T, delta Ng is 1. So this will be my equation.
The
Okay,
answer will be 0.153.
it will be 14.19 upon 0.082 into 1127, and it comes out to be
0.1532.
0.154.
0.15. Okay, 154. Okay, so this was a little bit lengthier question. You should be knowing these type of questions. Okay, then just see this question number 7.24. I think time is up. Because English ma'am also wants to take a class early.
Yeah.
Time up. So I am leaving you. But try all these questions till question number 7.23. Any doubt, you can send me on WhatsApp. Or you can ask in the class. You can take me time. I will explain either 5 minutes before or after the class. Okay? But try solving the questions. You can leave now.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.